Hello, everybody, and a very, very warm welcome to all those here in the room at ESMT Berlin, but also, of course, online, those that couldn't make it, that wanted to come. It's great to have you all here. It's great to have you all with us for the demo day of AdMaCom 2022. I'm particularly delighted because this is obviously the first time that we can meet in person for this occasion since 2019. It has been a roller coaster of a week that we had the startups here live in Berlin, which cannot be emulated by anything that is online. So it was really a great experience. There's also quite a lot of relearnings for the team and some learnings also in the sense of doing things online is quite easy. You post a Zoom link and then everything works. However, if you have to coordinate across locations and then also across offline and online, it's been a challenge here and there. And with that, I hope you accept that not everything, for instance, yesterday went as smoothly as we wished. But I hope today, which we've really been planning for a long time, and with Taha in particular being involved in the technology side of things, it's all set up. Right, now, what are we going to do today? The key thing is, of course, to hear the pitches from our startups, and then, of course, get the jury to select the AdMaCom winner 2022. We have got 3 prizes to be given away. One is the jury's winner, obviously, that's the overall winner. Then we have a crowd's favorite, so the crowd here as well as online can actually go and vote. And finally, we have the mentor's choice, which was kind of, in a way, perhaps the toughest selection because you get votes from every mentor and you've done loads of mentoring during the past couple of weeks. And on that, who performed best on average in these votes gets this prize. But we come to that later. In between, after the pitches, we have, of course, a little coffee break for the jury to take time. And then we have the award ceremony. We have some contributions from our members and partners that are supporting ENAM and or the event. And for those that are here, we finished today with a bit of old school networking, which means you stand at the table, you talk to other people live, you hold a glass in your hand and you drink, etc., etc. There is a networking opportunity. I'm looking for Chris to confirm this in the break for those that are online. So the startups that are online can be approached online via Zoom by the visitors that are online, by the participants that are online, and there can be some chats whilst we are networking over a cup of coffee. Now, for those that don't know us, I think here in the room I see many familiar faces, so I don't need to talk too much about what ENAM is and what we do, but for the online crowd, I'm not so sure. So let me just very briefly do my rundown, my ENAM pitch of what we do and who we are. So ENAM, founded actually 6 years ago, is an association, non-profit association, which aims to build a decentralized ecosystem around the technologies of advanced materials. What does that mean? That means we run competitions like this, we do innovation challenges, we do events, we do networking events, we do incubation programs with the goal to bring together the players that are in the advanced materials space. And that is obviously, as in any ecosystem, startups, innovators, it's the corporates, it's investors, it's very importantly research institutions, particularly in this field, and the public sector. And I'm very happy to say that we are very strong in all of these pillars that builds a good and great ecosystem. Now, moving on, this actually is it's the 8th edition of the AdMaCom. Why is that? Because last year with online and hence less time to prepare, at least what as the logistics are regarded, we ran 2 AdMaComs, one in spring and one in autumn. And we intend to do that this year also. So there's a second AdMaCom in autumn, which is shifting the focus slightly to the later stage startups, i.e. those that are gearing or getting ready to a structured funding round, be that a late seed stage round or be that a Series A round, so that have different needs to those that are, let's say, at the seed stage and are looking for angel investment, et cetera, et cetera. So that's coming up this autumn. We've had just a short rundown what we've had in the course of this week. The AdMaCom program has two very fundamental pillars. One is the training and teaching that you get in the workshops, and the other is the mentoring that you get from people from our network, i.e. people with expertise in various areas, ranging from technical expertise to legal expertise to finance expertise to go-to-market expertise, whatever it is. And that gives startups or participants a very, very detailed opportunity to go into these matter with their mentors. So you come out of AdMaCom with probably a bit of an information overflow, which you have to digest and have to work into your operational planning, et cetera, et cetera. But I think it's worth the while and worth the trouble. And from past startups, we know that they really appreciate the high degree of high density of information that is being presented. Now, excuse me. Now we actually have this year's AdMaCom, again, 2 weeks. 1 week was completely online, one was hybrid, as you well know, those that are in the room know. We had 11 startups from 6 countries, actually spanning the west coast of the US to Singapore. So time zone-wise, it was really a challenge, less so for us, but actually those that were in these time zones to be following the program. We had more than 200 mentoring sessions that I've mentioned already, and lots of training around topics such as pitch training, finance, public finance, IP, legal issues, et cetera, et cetera. And we're gearing up now to take part in the demo day that is taking place today. Our startups, you see them and you'll get to know them a bit more in detail in a second. Our startups, we have 11 on board for this round, and they cover a wide area of technologies. And this is probably quite representative of ENOM, because if one hears, okay, advanced materials, what could that be? It can actually be a lot. So we have on board this year, just to give you examples, and as I said, you'll learn more about them later. We have representatives from, let's say, the shipping industry working on anti-fouling coating for ships. We have a startup working on replacement materials for OLED production. We have a sensor startup. We have a vegan leather startup, et cetera, et cetera. So needless to say, a very wide range of technologies that we have. Each very interesting on their own, and who's going to make it winner today probably doesn't depend so much on the technology, but much more on other things, on the potential to succeed in the market. Now, the AdMaCom journey has also taken us, at least those that were in Berlin and those that were with us virtually, well, maybe they got a glimpse of the locations where we've been also, has taken us all across Berlin this year, from the west, where we were a guest of Berlin Partner. Big thank you to Garrett in particular, and Sylvia also for that. Robert Half, we went to Vista in the very east, the research area, Science Park. They also have been very great at hosting us. We've been to Sony, thanks a lot to Nino and Sam, who are also here today, kicked off the week actually there. And finally, we are here now at ESMT, business school right in the heart of Berlin. Now, obviously, hybrid means that things work a bit differently than you expect usually. I think we've managed really, really well, and especially Taha and Chris in the background, in a way, have managed really, really well to bring everybody together on time, on budget, and on quality most of the time. Again, yesterday was the exception that needed to be, so we apologize for that. And hence, we also moved around in the city in various ways, so there was a bit of fun on the side also, which there should be. But yeah, a big thank you to the team that was working in the background. It's been really, really great to get this off the ground after, well, 2 years of hanging in front of screens. Now, also a very, very big thank you, and that needs to be said, to our partners, our members, and our event sponsors, without whom the event obviously would not be possible. So thank you very, very much for supporting us in the long run through your membership, but also on the occasion through your event sponsoring. Thanks a lot for that. And now, without further much ado, I would ask Ferdinand, before we get into the starter pitches, to say a couple of words on behalf of the INAM board. Ferdinand has been member of the board and head of the board since 2017. And as a side job, he's also managing a high-tech company here in Berlin, which is growing to new successes as of late. Welcome on stage, Ferdinand.
Is that working, or should I can use this? Yeah. Well, hello, everybody. I cannot even express how excited I am to see you all here. And of course, welcome to everybody that is online. It has been more than 2 years now that we have had an offline meeting like this, and to me, it makes all the difference. I know online has a lot of advantages. You can be in every kind of time zone and it still works, but it's so nicer to see each other face to face, to have offline conversations again, and it's just a pleasure. In former times, I was used to speaking in a front of a crowd quite often, and nowadays I find myself even being nervous getting up here because I'm not used to it anymore. So let's hope that in the near future we're all getting used to it again, and it doesn't create such a level of nervousness. My very warm welcome to the center of our attention and the center of INAM and the AdMaComs, and that are the 11 startups that we have today here. I had the pleasure of mentoring some of them, unfortunately not all of them. The one that I mentored were really, really great, and what I heard from the other mentors telling me is the same. So I believe that the batch that we have in the spring of 2022 is a really exciting and a very promising batch that we have here, and we're going to see that in the pitches. And I'm sure as guests here and seeing them for the first time, you're going to be really excited to hear their technologies, to hear also their business acumen that they have. They are really strong entrepreneurs, and already now I wish each and every one of them the greatest possible success with in their adventure as a startup and for their business. Let it grow as fast and even beyond of what they're hoping for, very much so. One word to the team here. I'm just here and giving a few words. That's all. I didn't do much else. So a big thanks to the organizing team here. Asa, I don't know where she is sitting, somewhere here in the room, downstairs, and Taha, Chris, and Oliver that made this all happen. Without their work, without their restless engagement in INAM every year, even through this pandemic times, they kept the INAM up and running. This was an amazing achievement over the last 2 years, and that this event runs so smoothly, even if there was a little hiccup yesterday, I learned just now, I didn't even hear about it. I think that this is wonderful. This is wonderful work. Thank you very, very much. Well, and then my last word is to the guests here in this team. If you're not yet a member, not affiliated with INAM, let me remind you that for every single cent or euro that we are getting, we do get some government support. Yes, thanks to Garrett and a lot of government related institutions and partners that we have. But it all begins with the membership and it all begins with the sponsorship. So if you are sitting here and if you like what you see and if you like what we are doing, you might want to think about if you want to help us and making this even better, even higher in quality, even wider and even bigger. So be my guest. There are chances to become member. There are chances to become a sponsor. So there is not a certain spots that we have. We could still accept a few more. So if you like it and you feel comfortable with what we are doing, come closer, be a part of our team, be a part of ENAM. I promise you, you will not regret it. And with that, I'm eager and I'm anxious to hear the pitches. Thank you so much. Thank you.
Thank you very much, Ferdinand. Now, I do think that before we come to the pitches, we'll have a short look at the jury members. And if that is okay with you, I'd pass you around the mic for a short intro of yourselves so that both people online as well as in the room know who you are. I start with Konstantin.
Yes, hello, my name is Konstantin Hansen. I'm from the IBB, which stands for Investitionsbank Berlin. And I'm working in the business development department of the IBB. And we're also a sponsor of the AdMaCom. And I'm happy to be here today and be a part of the jury. Thank you.
Hello, my name is Ainara Garcia. I'm coming from Spain, from a research center, Cignanogune. I'm the technology transfer manager. So mostly we work with materials, advanced materials, nanomaterials, and so in our center. And I'm really looking forward to this event today. Thank you all.
Hi, I'm Tonino Greco. I'm from Sony. Apart from having the honor to be in the jury today, we are also member of ENAM, so I can only sustain Ferdinand's addressing words. Please join. You will not regret it. So, yeah, pleased to meet you.
Ferdinand is passing. Hello, everyone. Gerrit is my name. I'm from Berlin Partner in charge of the Department for Optics, Photonics, Microelectronics, Quantum Technologies, and also Advanced Materials. We are a founding member of ENAM. And of course, we're very proud of the achievements that have been there in the past from the ENAM. Also, some startups who have settled here in Berlin, started their business and their business development here. And we are highly appreciate that there is so much demand on participating in the event. I'm curious to see what the startups are up to. And it's a very much of a pleasure to be here in the jury today.
Hello everyone, this is Andrea Cadelli from SAIS Red Zone. SAIS is an Italian multinational company working in the field of advanced materials, and I am personally a materials engineer, so I feel quite comfortable being in a place like this, involving innovation and startup and evolution of the technology towards the future of materials and of this for this planet. So thanks, Oliver, for having us here together.
Thank you very much. And now it has come the time to actually look at our startups. And we're going to start with Mars Materials. Aaron.
Is this a good spot? Happy Friday, everyone. I'm Aaron Fitzgerald, CEO and co-founder of Mars Materials. We're working to store captured CO2 into long-lived products like carbon fiber. We're commercializing process technology called nitrylation that enables us to produce low-cost, low-carbon acrylonitrile, the main raw material for carbon fiber. As cities like Berlin seek to reduce their transportation-related emissions, carbon fiber can be used to lightweight vehicles, to improve fuel efficiency, and to increase EV battery life. Acrylonitrile is a large commodity material. It's valued at nearly $12 billion per year. And it's used in a variety of long-lived products like thermoplastics and fibers, flocculants for wastewater treatment and paper pulp manufacturing, and carbon fiber. In the areas of flocculants and carbon fiber, there's enormous untapped growth potential that could lead to gigaton scale emissions reductions impact. To better understand the key limitations that's really limiting these flocculants and carbon fiber markets, we conducted discovery with all 3 global acrylamide flocculant manufacturers and 5 of the 10 largest carbon fiber manufacturers. And what we learned from them was that the conventional process that's it is limiting their growth potential, their ability to provide stable supply of their products, and to reduce costs. At Mars, we see an opportunity to solve a customer problem. The conventional petrochemical process is responsible for nearly 90% of the world's acrylonitrile production. And it takes crude oil and it converts it into acrylonitrile and toxic byproducts. Our process takes captured CO2 and ethanol and converts it into pure acrylonitrile. It's game-changing. And not only that, at full scale, we anticipate cheaper production costs, cheaper CapEx for plants, less process emissions, all while using captured CO2 and the equivalent of removing about 9,000 vehicles off the road. Our material is a drop-in replacement, and we intend to sell it to the acrylamide and carbon fiber manufacturers. And we're at our commercial units, we anticipate revenues of about $72 million per year, with gross margins starting at around 25%. And with optimizations, we see a path to 40% margins. Our go-to-market plan consists of 4 key phases. And today we're working on phase 1 and phase 2 concurrently. We're producing grams and then kilogram samples for partial validation in our acrylamide beachhead market, and then full validation in the acrylamide market. From there, we'll launch our first-of-a-kind demonstration plant, and we'll be able to seek full validation in the carbon fiber industry. In phase 4, we anticipate launching our first-of-a-kind full-scale plant with a production capacity of 50 kilotons per year. And the main differentiation factors really moving the acrylonitrile market today are cost and life cycle. Global producers have been described as having regional oligopolies. New entrants like econitrile and trillium are focused on renewably derived material, but only nitrylation can reduce the costs that will enable carbon fiber for vehicles for lightweighting. This will not only balloon the acrylonitrile and carbon fiber markets, but will also improve fuel efficiency by an estimated 7 to 29%. We estimate launching 70 nitrylation plants over a 20-year period will lead to gigatons of emissions reductions. And my team and I were small, but energized, with backgrounds in commercialization, scale-up, and carbon removal research. Our advisors also helped to unblock us, including the technology's inventor at NREL. And our milestones are adding up. In less than a year, we've secured commercial rights to our IP with the National Lab. We've closed an oversubscribed pre-seed round. And as we continue into 2022, that momentum is only continuing. We're in joint development conversations with acrylamide manufacturers and sample transfer agreement negotiations with them and carbon fiber manufacturers. So today, we're seeking to partner with members of the ENOM community to help us with our scale-up work on commercial optimizations. We have 4 key projects, and we're looking for experts who can help us with downstream distillation and separations processes. We're looking for experts who can help us with developing life cycle assessments. We're seeking experts who can help approve upon Fluor's FEL0 capital cost estimation for an FEL1 and FEL2. And we're looking for experts who can help us design our first-of-a-kind demonstration plant. And what you would get partnering with us is a strong and energized team that's fully committed to our mission to do financially well and good for the planet. And with our powerful technology, we can create a future where cars are lighter, where steel is replaced with carbon fiber, and where atmospheric carbon is repurposed for good. So join the Mars mission today, and I'm so excited for questions in the booth.
The jury may now ask questions. You can use your mics. There should be a button, yes, like in your days. And then it will be broadcast to the people online also. But please go ahead.
Thanks, Aaron. Thanks so much for your presentation. Very sharp, very clear. And just a question about the material itself. I would like to ask if you can argumentate a little about the properties of the material. If you expect they are similar to current acrylonitrile materials we can get from crude oil production, or rather if you have different properties which might be even improved with respect of the current technology. Thanks.
No, in fact, we chose this technology because it produces a true drop-in replacement. And why that's important is particularly in both of our markets, the acrylamide industry and the carbon fiber industry, these materials the formulas are extremely tight. So particularly in carbon fiber, the manufacturers care about a true drop-in that can mix in with their existing supply. So the reason why we have to go through these 4 stages of material testing is in fact to make sure that there are no differences in the material.
Thanks.
You're welcome.
A quick question on your pilot line. Is that a pilot line which you have to build from scratch, or can you utilize the existing chemical infrastructure of some site?
And by pilot line, do you mean in our phase 1 and 2 work, or in our demonstration plant?
In your
yeah, so our technology, what is patented is the process itself, which the claim involves taking a carboxylic acid and an ester over a solid state catalyst to produce our nitrile derived material. And the equipment itself is is units that we can use that are off the shelf. So we will have to design our own demonstration plant, but the equipment and the bill of materials are ones that we can kind of just source from existing facilities. You're welcome.
Any more questions from the jury? It seems you explained it well, Aaron.
Hopefully. Thank you so much.
Thank you. So, next one up, we have a online representative, an online finalist, and we are switching over to low sulfur fuels. Good afternoon, Glenn. The stage is yours.
Glenn, you need to share your slides.
Apologies, I thought I was number 3, not number 2, but let's go.
Super, we see it well.
Great. Good afternoon, everyone. Thank you very much for inviting us today. My name is Glenn Halliday, and I'm the co-founder and COO at Low Sulfur Fuels. And thanks also to INAM for inviting us to participate in this really interesting event. I don't know if you're aware, but there's almost 500 million tons of valuable used materials generated every year that are looking for recycling solutions. Currently, EU consumers generate almost 3.5 million tons of used tires and almost 30 million tons of used plastics every year. And there's currently no proven methods of processing that or recovering it at scale. LSF has developed a radical electrochemical process that handles used tires, plastics, and lube oils and produces valuable recovered feedstocks. We're also able to deliver emissions reductions as well as supporting the Sustainable Development Goals, SDG 9 and 12. In simple terms, we heat our input feedstocks to a gas phase. We then inject a proprietary electrolyte into the gas stream. Our electrolyte reacts and cools the gas to produce a raw distillate and electrolyte mix. We separate and solvent wash the raw distillate to produce a bright, clear final distillate and other valuable outputs. These outputs can be used to make new chemical feedstocks, rubbers, plastics, and other valuable products. Our USP is that we produce an output that is highly saturated with only trace levels of contaminants. And this is in high demand with major refiners and recycling companies. We also are confident that many of our competitors can't match this. Our technology advantage is that we've identified and simplified our process, and we use many proven industrial components. And as such, we have a lower CapEx and OpEx. Our feedstock flexibility is also advantageous. There are major global markets for our technology and the valuable outputs that we produce. The outputs can be sold on local or national spot markets or direct to industrial off-takers, which is our preferred route. The foundation of our business is in Europe, and this is going to be the springboard to the US, MENA, and Asia regions. We will generate revenues through owning and operating 4 strategic innovation hubs in Europe, the US, MENA, and Asia regions. And these hubs will then support the licensing of our technology with partners or through joint ventures in those regions. We've made consistent progress strategically and commercially in the UK and the Netherlands. We also have agreed LOIs with Dow Chemicals and Continental, and we recently restarted paid testing earlier this year. Our financial projections for the next 5 years are based on our current operating and licensing funnel, and on the assumption that we'll have 29 units operating within that time frame. And we'll start with the first unit being located in the Netherlands. We're currently raising a 1.2 million angel round, and it's almost 50% secured. We have agreed a term sheet with the Low Carbon Innovation Fund recently. The purpose of the raise is to allow us to complete final feedstock testing and the basic design for our first full-scale production unit. John Taylor and I have more than 25 years experience in the oil, gas, and chemicals industry, as well as delivering technical and commercial projects at scale. We've also identified we've run a very lean team for the last few years, and we've identified a number of key people that we need to hire post the close of our angel round. We expect LSF to be more than 100 million euros revenue company within 5 years. And we're making a substantial contribution in that time to emissions reductions and sustainable development goals. We want to improve our world, but we need your support to achieve that. We have the technology, we have the capabilities and the people to do this. And we'd like you to join us, to invest in us, and be part of that positive change. Thank you for listening.
Thank you very much, Glenn. And over to the jury. Questions?
Glenn, a quick question from my side. You mentioned that you can use used tires. In which form you can bring them into your process? You can take them as they are, or do they need to be grinded? Or what is the pre-processing before you can take it into your process?
Thank you very much. We definitely don't want to take whole tires, because fortunately there's already an established industry that will pre-treat tires, and we'll be able to get them in a format, shape, size, and spec that we require. So essentially they will come in pre-shredded.
Just for my clarification, the final product then is a liquid, it's a distillate that you have. What is that correct?
That is correct. When we process tires, we typically produce what we would call a middle distillate, which ultimately can be refined into making rubber products or other similar polymers. If you take plastics, we typically produce a lighter, more like a naphtha type product, which we're able to then have cracked and used to make plastics.
So your end customer would be the refineries or capable chemical companies that can handle this type of distillate?
Correct.
One more on the recycled stream. There is already a standard recycling process for tires. They grind them and they make some floorings out of them, or so I think. Is that a competitive process there which you have to buy in? I mean, you have to buy tons or truckloads of used tires from people that are already using it for something else? So how does the financial side look for the incoming material? Or you get it for free?
I wish we could get it for free, particularly being Scottish. That would be really helpful, but no, unfortunately not. So the reality is, particularly within Europe, that's part of the reason we're going to go to the Netherlands in the south of Holland, because we sit what's called within the ARA hub, which is the Antwerp, Amsterdam, Rotterdam hub, with significant quantities of raw materials flowing through there on a daily basis. The reality is that there are a number of outlets for used rubber tires. However, those are difficult, challenging businesses. And they're also faced with a potential challenge that the European Union has been looking to potentially outlaw the use of recovered tires in those types of applications that you mentioned. So that's clearly not good. But as far as we're aware, and we factored into our financials that we will be able to acquire the materials that we require as a feedstock. And the good thing is there is an established industry that's already delivering those types of materials that we require at some scale. Does that help?
Yes, thank you.
Any more questions from the jury? Tonino?
Hi. Your process seems to be quite energy loaded, so you need to probably a lot of heat to bring your components into the gas phase and then redistillate, etc. So how does it compare when from a cost perspective of your products, this naphtha or whatsoever you can produce? Is that competitive on the market? I mean, from production costs, and also how efficient is your process? So what is the residual you get out of it?
Those are very large questions that I probably have only 5 or 10 seconds to answer. So I'm not going to be rude, but I'll try and give you the high level. I mean, you know, the reality is that because we deliver a highly saturated, very low contaminant feedstock or output, that allows us to not have to do lots of post-treatment. Many of our competitors, when they sell their products into the marketplace, the refiners and the people who are accepting these are having to do significant amounts of additional work and cleaning with some significant environmental impact. And so as far as we're concerned, although you're right, we do have to gasify, everybody is doing that. It's almost what comes after that that differentiates how much energy and power are we using. And so that's why we see ourselves as being significantly more effective and more efficient. Would be just a really kind of high level answer to that one. Is that okay?
Yeah, thank you.
Okay.
I have one question.
Who's that?
I hear it.
Okay, sure.
Thank you for your very interesting presentation. I'm from Nitto-Denko, Germany. I'm a researcher. Actually, I'm very interested in your technology. So I have 2 questions about your technology. So I'm especially interested in the plastic recycling to naphtha. Actually, is your process relating to a pyrolysis or electrochemical method? Firstly, I would like to confirm.
The short answer is yes, it's both. Essentially, we have a thermal process on the front end. Some people call that pyrolysis. We operate at a lower pressure and a lower temperature. However, at the very core of the process, we have an electrochemical process that allows us to generate a very special proprietary electrolyte that allows us to do different things with the gas stream. Much longer answer, I'm trying to keep it tight.
According to your website, you need some mechanical separation process before plastic to naphtha. So what kind of process?
No, you're absolutely right. But maybe let me just clarify that. What we mean is that we will only look at plastics that are available after mechanical recycling has been done. In other words, it's cheaper to mechanically recycle first, to take the easy plastics out, and then you're left with the more challenging ones. And that's typically the area that we're looking. Does that make sense?
What types of contamination are not unacceptable for you?
That depends on the feedstock, and I suspect is just beyond the scope of our conversation right now. That's a super nitty-gritty one. Happy to talk about that, but it really honestly depends on what the inputs are. I mean, we're fortunate we can handle PVC and other raw materials that many of our competitors can't because our process isn't upset by those.
Thanks very much for the additional questions. Of course, if there's need of anybody or desire to be connected to our startups that are not here today, we are of course happily the broker of this connection making. So just reach out to us and we'll set up the connection. Now, next one up is we take a journey to Singapore, I think, and Elmira of Crosslinker will present her startup.
Hi, can you see my screen?
Yes, we see you and your screen. Perfect.
Good. Hi, everyone. My name is Elmira, and I'm going to talk about Crosslinker journey and our mission to enable the world with better ways to be more energy efficient. Crosslinker is an innovation-driven clean tech startup. We are a seed stage company founded in 2019, and we are located in Singapore. We are focusing on energy efficiency through development of an advanced super insulation material called aerogel for challenging thermal insulation application. Thermal insulation is the most effective and least expensive method to reduce the demand for energy. And aerogel is the best material to do that. Aerogel is a porous and ultra lightweight material with the highest insulation performance of any non-material on Earth. But despite the huge potential, and aerogel hasn't become a booming commercial reality because of the several barriers, mainly very long and energy-intensive production process that makes it very expensive and puts it out of reach for several verticals. With our patented aerogel platform technology, we are addressing the major limitations in traditional fabrication and formulation of aerogel. Our platform technology integrates advanced chemistry and processing technology to produce aerogel 3 to 10 times faster, 5 times more energy efficient, with 100% water-based and green formulation. This yields high performance, cheaper aerogel as compared to traditional technique. We are unlocking the potentials of aerogel for several high-value, high-growth markets, which are heavily reliant on thermal insulation. Our first focus areas are cold chain, building insulation, and electric vehicle battery system. Cold chain packaging is our beachhead market. I'm sure after COVID, there are a lot of awareness, but it's not just vaccines. Millions of biopharma products from blood, vaccines, and clinical trial samples are sensitive to temperature, and they get killed in their shipping journey because of the temperature breaches that happens during the shipment or storage. This is mainly because of the dearth of high-performance insulation material. Our aerogel packaging shippers offer the best thermal protection. This means no more damage to valuable biopharma product. And shipping costs are 20% lower in every single shipment because of thinner and lightweight packaging solution. And better yet, it is reusable and truly sustainable. Over the last 3 years of development, we have designed first of its kind platform for fabricating aerogels. We also developed 2 lead products, and for the first line of product, which is silica aerogel in the form of composite board panel, we have successfully completed the validation trial with biopharmaceutical packaging company. Our product is now ready for commercial launch, and we are going to scale up our process to the pilot scale production next year here in Singapore. Here is our team. Crosslinker is founded by a team of 3 scientists and entrepreneurs. Gayatri, Mahesh, and I bring to the table more than 20 years of experience in materials chemistry, manufacturing of advanced material, and commercialization of insulation technology. Currently, we are a team of 13 people with few key strong hires and few business and domain advisors from the field. Driving towards ESG net zero targets and UN sustainability goal is at the core of what we do. By making aerogel accessible and affordable to global insulation industry, we reduce carbon dioxide emission and also open the way for the circular economy. We invite collaboration and strategic partnership in other insulation verticals, not only cold chain and the other thermal management system. We are also raising Series A fundraise to launch our products and protect high value biopharmaceutical products during their shipping journey. Please join us to change how the insulation works today. Thank you very much.
Thanks a lot, Elmira. Over to the jury. for questions.
A quick one from my side. How you recycle it? Let's assume you have it for building insulation. What is the way to recycle the material?
So we are still not targeting the insulation market for building industry, but for the cold chain packaging application, which is our beachhead market, there are a reverse logistics system in place. So the whole industry is moving towards the closed loop system. So there are systems in place to get the package back. So our plan for end of life of our product is like a few approach. We are going to recycle, refurbish, and remanufacture it, and after like a few cycles, we can also repurpose it to some other low-end applications, such as construction market, for example. So recycling, because this is a silica-based material, is through mostly the mechanical recycling. So currently in our process, we are using up to 20% recycled compound based on the waste that we are generating in the current productions in our facility.
Thank you.
You're welcome.
More questions? Yes, Garrett.
I would also like to ask a question about your production process and the superiority of your process. Probably you don't want to go into the details, which I understand, of course, but maybe you can give us a bit more of an understanding where your core competence is when designing your platform. And a question number two, whether or not you are already working with partners when it comes to setting up your pilot process.
Thank you. So the platform that we are developing basically has two components. One component is on the main drying technology that we have developed, which is faster and more energy efficient compared to the traditional supercritical drying that requires very high temperature and high pressure reaction conditions. So that's why we would be able to produce aerogel much cheaper compared to the existing technology now. So on the formulation side, because of the new technology, we are also applying 100% water-based formulation that makes it very green and eco-friendly as well. And on top of that, we are also producing the aerogel in very versatile form. So far, aerogel has been into market in the form of either particle or a very thin blanket product, mostly for oil and gas industry. So this is the first time that we are producing aerogel in the form of board panel. We can manufacture from like a 5 mm all the way to 50 mm. We don't have any limitation in the thickness or form of the products. So in terms of the pilot scale production, so based on this new technology, we have done all the prototyping, designing the mini pilot production, and we are already manufacturing in our current facility, like the sheet size of like up to 40 cm by 40 cm, which is good enough for completing all the trials with this packaging application. So we are going for the pilot scale production, which is a capacity of close to 1,000 packaging shipper per month, with our first customer in 2023. So this is going to be done like 100% by ourselves here in Singapore. But beyond that, we are also shortlisting some manufacturing partner that could help us to scale up and go through the mass manufacturing. So for now, we are taking the kind of cautious choice to take a middle ground, and there will be other business model that we could potentially practice besides the manufacturing model.
Thank you.
Okay, Tonino.
Maybe another short one. So as far as I understood, so you've developed a new process where you can dry faster and more efficient. The resulting, say, aerogel, you're not limited by thickness, which is quite impressive. So, but how does it compare to, let's say, traditional ones in terms of stability, mechanical usage, or does it just powderize the moment you just touch it?
No, so this is very different from the traditional aerogel, like a monolithic aerogel that you see in like a Google or YouTube videos. So we have worked on the mechanical strengths of the product, and the product is very rigid. So the look is very similar to kind of a styrofoam product. So it's very rigid, very strong in terms of compressive strengths, because we are targeting the packaging application. So packaging is a mobile application that exposes the package to a lot of vibration, a lot of drop tests. So the product is quite mechanically robust compared to the original or like a monolithic kind of erosion that you see. So another challenges that we have solved with our technology is the dust issue. So the current products are quite dusty, the blankets. So the pharma industry cannot tolerate any level of dust. So we have addressed also that issue, and our product is very, very low level of dust that could suit and enter other verticals other than the typical oil and gas industry.
Maybe another one quick. Are you limited somehow to silica, or could your technology open up any material?
So our current focus is only silica, but in our patent application, when we were proofing the potentials of the technology, we have tested other formulations, like such as the polymeric based or cellulose based kind of material with our drying technology that we have disclosed some details in our current patent. But for sure, like one of the future development is to expand our product offerings beyond the silica, go to like a polymeric based or carbon based or bio-based materials besides silica.
Yeah, sounds too good to be true. So what do I have to do to get a sample? But maybe we can discuss that later.
Yeah, for sure. Yeah,
thank you.
Yeah, happy to send.
Super, thank you. Ainara, please.
I have one more question. So Elvira, this is a question regarding your IP strategy. So you said that you have a patent application and that will be protecting the process, I guess, or is the product by process? I mean, are you protecting the process of synthesis? Or
yeah. We have two patents at the moment. So the first patent, which is our core technology patent, is mostly the process patent that cover the complete production process of making aerogels. So we also cover some of the product properties, but we are not disclosing our formulation. So the formulation and intricacy of the design of our novel technology always remains our trade secrets. So we have few trademarks as well. And with different applications that we are targeting, we are also going to file few other application patent as well. So currently our first patent is in the national phase entry. We have already filed for 6 different countries, including Germany also, based on a customer base, competitor base, and also the manufacturer to secure some manufacturing sites that we can manufacture aerogel much cheaper than Singapore.
Thank you.
You're welcome.
Okay.
There's actually a question from the chat from the online audience. Do you already have pilot customers?
Yes, so over last 1.5 years, 2 years, we've been working very closely with this specialized biopharmaceutical packaging company. So they are our immediate customer for the first cold chain application. So we signed a partnership with them, went through all the industrial trial and already certified our product through a standard called universal testing of ISTA 70, which is the certification that is required for market entry. So we have already completed all the trials with our packaging company customers, and we go for the soft market launch soon by end of the month to secure some commercial orders before we go and scale up to the pilot scale production early next year.
We assume the question is being answered with this. Now, thank you very, very much, Amira, and round of applause to you. And next one up is another local startup, and it's Montgomery, straight out of Darmstadt this morning for Lover.
Thank you, Oliver. Hi there, my name is Montgomery, and I'm the COO and co-founder of Lover. We produce the world's first 100% plant-based leather alternative that is made from agricultural residues. Why do we do that? Well, because leather production is a mess. There is no leather production without animal suffering, and even post-slaughterhouse, the tanning process involves tremendous carbon emissions and the use of harmful chemicals. And the alternative that the industry has come up with, synthetic leather is no better, because synthetic leather is made from crude oil, it causes microplastic abrasion and is not recyclable. So this is where we get into play. Lover is here to clean up. Lover is leather-like, oil-free, vegan, and residue-based. The main ingredient of a product are agricultural natural fibers that would actually go to waste if we didn't use them. Currently, we're using hemp fibers because hemp is an easy plant that doesn't require pesticides. It is a carbon sink and it is increasingly grown in the markets that we're targeting. The material that we then have is a plastic-free material that saves almost 100% of carbon emissions compared to genuine leather. And the product can be very easily processed with standard machines due to its monolate and heat-resistant structure. And really these are the advantages that multinational textile processing companies are very interested about Lover. And also we can vary the thickness, the size, the structure, and the surface, and the colors of the Lover material. But of course, Lover is not the only so-called vegan leather alternative that is out there. So let me just give you a quick overview of our competitors. First, there are mainly European startups, and what they do is that they have a generally scalable production process, but they have two problems. The first one is they have multi-layered and plastic containing products. And the second problem they have is that they use fibers that are either scarce or that are not so easy to handle, which has led in recent time to substantial supply chain problems. Then there is a second group of very well-funded US startups. And what they do is they actually grow leather in the lab from cellulosic fibers or protein-based fibers. But since they work in batch processes, their production process is simply just too expensive and they haven't been able to scale up. So compared to our competition, what Lover has is that it is both sustainable and scalable, because with our patent pending technology, we're able to use a continuous production process. And as you can see here on the pictures, we have already been able to run our first production trial and really produce Lover by the meter. So these are the guys behind the product. We are old friends from back in school. We have a very strong network that supports us of industry and academic experts, and we are steadily growing. We have now 3 employees and are hiring a 4th one. And this is actually what we do. So we test and further develop our product at the Technical University of Darmstadt. We work closely together with regional hemp suppliers and contract manufacturers to keep supply chains short and the CapEx requirements low. And we then sell Lover by the meter, and Lover is planned to be licensed, and actually the role model that we have in mind when thinking about our licensing strategy is Gore-Tex, so that you have a reference. We're already in close contact with a lot of companies for material testing and developing prototypes. For example, German clients, but also multinationals from the fashion industry, furniture producers, and also the automotive industry. And we have already produced prototypes, that is accessories, shoe insoles, one of our first use cases, and other shoe components. Also, we are about to close our seed funding round of 1.3 million euros for the upscaling our patent strategy and a runway of the upcoming 18 months. So we're here actually today to look out for potential interested strategic partners that are willing to help us improving our material, especially improving the recipe. And yeah, we're really looking forward to later on to the networking. And yeah, this is the Lover material. It is the possibility of change in our hands, and we want you to become a part of it. Thank you very much.
Thanks a lot, Montgomery. Now over to the jury.
I have a question. So, a very good presentation. I see that you have the scalability covered, and you have also the IP covered, right? You also have identified the end users, probably, and you have some products in mind, right? My question is more related to the properties of your materials, yes, because I guess that each end user is looking for different kind of properties. It comes to my mind, for example, if you use the same leather for jackets that are used in motorbikes, for example, they might be interested in the resistance to abrasion, for example. But if you use the same leather for cheaper, like textile, maybe you are looking for something that is low cost and has other kind of properties. So it's quite transversal, right? Yes. So do you have like a priority or like a strategy in mind to cover these different types of markets?
Yeah, thank you very much for this question. That is absolutely right. And also this is one of the reasons why the shoe insoles are our first use case. Because, yeah, to be honest, even when it comes to the UV resistance and like, yeah, light resistance, we do not achieve like the requirements that are used in the automotive industry now. And even if we would, the go-to-market could be 5 years with an OEM. So actually, what we're doing is we're planning in different product classes. So at first, we're going to go for applications that are easier for us to reach, where the material can be a bit stiffer. We also have like softer qualities, but of course, we are planning to successively enter the markets and widen the applications with time.
Mm-hmm.
Yeah.
Thank you.
Yeah, maybe.
Oops. How does your final product depend on the quality of the raw material? You mentioned you are currently using hemp.
Yes.
So if that varies, how does that impact the final quality of your product?
Yeah, thank you very much for this question. Actually, we've run several tests on the hemp fibers, and since we treat the fibers themselves, and this is really the big part of our IP, if you want, treating the fibers, actually the input does not really matter. So we have tested fibers for €5 a kilo and fibers for €1 a kilo, which were had like were of less quality, but in the end product you couldn't really tell the difference. Of course, for here I have an example of bleached fibers. So those are pre-treated fibers. This of course is then different, but besides that, it doesn't really matter. Yeah.
Thank you. Thank you.
I would also like to forward a question. You mentioned that you're using hemp as your raw material. Where do you plan to source your raw material from? I can imagine that there might be intensified hemp production in the future, also in Germany or in Europe. But are you considering, in the case of scaling up your production massively, are you considering to source your material from Europe? And do you have any partners in discussion already, or are you considering a worldwide sourcing?
Yeah, thank you. So actually, right now we're mainly working together with German suppliers, but also with European brokers and with suppliers, especially from France, because France is by far the biggest hemp grower. And like from what we can tell from the market, there is no shortage for now for the European market. But when it comes to the global scale, our IP also covers other natural fibers, and we have already also worked with other fibers. For example, cotton linters, so everything that is not used when cotton is processed, for example, because we cut down the fibers and can use fibers of lesser quality. So we can use fibers that are locally available. Also, we have also worked with banana fibers, which are also an agricultural residue, and actually they also work with our process. But for example, markets like USMCA, of course, there is a lot of cannabis or hemp grown in this market. Yeah.
Maybe one more question? Sure. Yeah,
Go ahead.
About the durability of your leather. So you have any artificial agent studies compared to real to genuine leather? So how your product is compared to this material?
Mm-hmm. Yeah, thank you. So actually, yeah, we compare very well when it comes to a lot of parameters with genuine leather and with artificial leather. There are some things that don't work for now. For example, when it comes to elongation, synthetic leather has a bigger elongation, for example. But for example, even the genuine leather that is nowadays used in the car industry has a PU coating. So actually, what you touch when you get into your car there is no real genuine leather for now. So of course, like either the car manufacturers would have to change their specs so that one day we will get in with the material and the recipe that we now have, or otherwise we would be forced to find a compromise to get into this market. So this is something that we haven't had to figure out now, fortunately.
Okay, thank you.
Yeah.
Well, thanks a lot, everybody, the jury particular, and most particular at Montgomery. And we will be moving on now back online to the US, and Animal from CM Materials will give us his pitch.
Good afternoon, everyone, and good morning who is in the United States. Can you hear me well?
Yes, we hear you well.
Excellent. Thank you very much again. I appreciate it. My name is
You're going to have to share your screen. I'm sorry to interrupt.
Oh, I'm sorry. I just went into the zone. Can you see my screen?
Yes.
Great. Thank you very much again. My name is Aminul Mehedi. I'm the CEO and founder of CM Materials. I would like to start with two stats. 60% of all the electricity that you produce is lost during conversion and distribution. And all that 50% of all the electricity that we generate in the whole world is used and consumed by motors and pumps and compressors and all that. And those are the equipment and the devices that we use for power generation and conversion, like motor, generator, transformer, inductor, inverter, DC-DC converter. Electromagnetics is a very important part of it because the fundamental physics is based on the electromagnetics for all of those devices. We are commercializing new material for more efficient and lightweight electromagnetics. Before jumping on the technology, I just wanted to give a little bit about myself. So I'm the CEO and founder. This is my second company. The first company we did still on a different magnetic material that we discovered while I was in grad school, and eventually we licensed to Seagate. After that, I worked for Tesla and Carpenter Technology. Both Carpenter is a magnetic material producer. So both my experience here helped me to learn what is the need in the market. So the unmet market need. So this is the problem that I figured the market has. So it's a 4 kilowatt inverter, and you can see the magnetic devices like the inductors and chokes are pretty large, almost 40% of the footprint covered by electromagnetics. Semiconductor takes a very small part of it, like this. And the problem why the magnetic is so large is limited by the magnetic material availability. There is no material available which can be efficient and smaller at the same time. So that's where the problem is, and we came with a solution where we can provide high magnetic induction material and low core loss material, which means we can provide a smaller machine and higher efficiency at the same time with a reasonable pricing. We just don't have enough time to go through all the numbers, but here the bottom line is if you have a high magnetic induction, that leads to a smaller device. You have a high electrical resistivity, which leads to a higher magnetic efficiency. We can provide, like depending on different materials, so we can provide 25 to 50% better induction, meaning smaller device. At the same time, the resistivity of the material is almost 4x. If you convert it to magnetic efficiency, it's going from 20 to 50% better efficiency from our material. And we are the bill of material and cost of manufacturing for our material is par with the commodity material that is available in the market right now. So we have two products, one called CleanMag. It's a unique solution for power inductors that goes into transformer and inductor. It can reduce the size of the inductor by 50% and increase the magnetic efficiency by 25%. So this is how the value chain looks like. So we make the powder and we also make the magnetic core. Those are both of our products that goes into the inductor, that goes into the power converter, and eventually go into the OEM after that. And the end applications is onboard charger, inverter, DC-DC converter, goes into EV, data center, consumer hardware, solar, and wind turbine. We have another product called CleanLam, which is a high efficiency solution for stator and rotor, goes into motor and generator. We demonstrated 50% better magnetic efficiency using our product. And this is how the value chain looks like. We create the coil lamination that goes into stator assembly and that goes into motor assembly that is made into a motor, and eventually OEMs get that. So we have two main applications in the motor space. When the traction motor goes into EV, a servo motor goes into HVAC, surgical tools, industrial tools, manufacturing, robotics. One important note from our customer we learned is like the market is going forward with higher frequency and higher speed machines, and this type of material would be very important for the future. Our key value proposition, as I already mentioned, is more efficient and smaller device, but also because it is more efficient, the machine will be cooler, and also because it is cooler, the machine life goes up. For every 10 degrees Celsius reduction of temperature, machine life goes up by 2x, and overall operating cost will be lower. We are going towards a market of $10 billion with a 6.7% CAGR, and it will be 2x in 10 years. It's also important that our material is sustainably sourced. We are not using any nickel, cobalt, rare earth, or any critical element. It will help to reduce 2.6 billion tons CO2 emission, and most importantly, the technology will be locally made and sourced. We have a very strong team very strong engineering team, and we have 13 sample orders from tier 1 and tier 2 suppliers. We have 2 joint development ongoing, which has overall a potential sales volume of $63 million. We are looking forward to have a joint development agreement outcome of this demo day. We are still raising between $500,000 to $1 million as a pre-Series A towards our Series A, and we are also looking for potential future manufacturing partnership. Thank you very much for your time. I appreciate it. If you want to reserve a 30-minute time anytime today or next week, I'm available. Have a nice day. Thank you.
Thank you very much, Animal. And over to the jury, as usually. Ferdinand.
Yeah, I have to ask first, these type of magnetic materials have been a field of research for something like 120 years now. Well, since the beginning of electrification, more or less. So what is the birth story of your material? How did you come up with that?
Yeah, yeah, thank you very much. So I just didn't have enough time today to go through the whole story. So the story is, so when I was in grad school, I discovered a new material called mine alloy. So we named it after where I was going to school in Minnesota. And we commercialized that alloy, eventually sold it to Seagate. So I wasn't super happy with that exit because my goal was to make that company larger. But the challenge was the material wasn't manufacturable in large scale. It can also only be done in like 20, 30 nanometer thin film in a repeatable manner. So that was my cue. Like there's a problem I figured at that point, but there's no material available for that. So from 2017, after that exit, since 2021, I spent my own money and resources, kind of bootstrap the whole material discovery. I went through the whole material discovery phase. So I found smaller foundry and heat treatment lab and smaller facility and fragmented the work in a way that nobody exactly know what they're doing, but I put together everything. So it was kind of my side project for 3 years to figure out something. In 2019, I had an aha moment. That I knew I stumbled into something because I figured that there's a composition we can do which can provide both the high magnetization or magnetic moment for device as miniaturization and high resistivity for high efficiency. It's just the passion and my risk taking, like in from 2017 to 2021 to figure out the thing. And when I figured it out in 2019, so I took a little bit time to start the company because 2020 was an awful year to quit day job. So I waited until 2021, and that's how we are here.
Any further questions, Ferdinand?
Well,
the mic's not on.
Yeah. Okay. Your material is a powder material, which is possible to sinter that, compact it, sinter it like a conventional magnet material, like the industry is doing that today. Is that correct?
Yes. So we have so this is a platform technology that can be used in the powder form or coil form. So we are doing powder for inductors, and we are also, that's available for the regular powder metallurgy route. We also have this clean lamp solution, which is like a coil and then can be used in the stator and rotor of motor and generator.
The conventional production process specifications are known. We can Google them for standard magnets. How compatible is your process to a conventional magnet?
So this is, all right. So conventional, so if you say conventional magnet, I think if you're referring to permanent magnet or the hard magnet like neodymium, iron, boron, and all that. We are not that type of magnet. So there are two types of magnet. One that you can stick to the fridge. That's like that magnet doesn't need any electricity to generate magnetism. And there's another kind of magnet, like a piece of iron, which you need electricity to pass through, and then it creates it's like called the soft magnetic material or electromagnetic material. Now, you asked about the process of scale up and what is the process to make it. For making the powder into a magnetic core like this for the inductor is the regular powder metallurgy route we are taking. So it would be a drop-in process solution. And for making a stator and rotor for motor and generator is the same process. We are making the process in a way that it can be the cheapest for anyone to adapt. So it will be pretty much drop-in.
Thank you. Thanks a lot.
Thank you.
Okay. Okay, Andrea.
Just
quick one.
Yeah. A question about the market entry strategy you might have in mind. You mentioned many possible markets, but the question is, which is the one that, in your opinion, is more prone to accept an innovation from a material point of view?
Yeah, very, very good question. Again, I just didn't have enough bandwidth to go through the detail of market. We did a very extensive market discovery. And as I said, my last job, I was pretty much doing the commercialization. So I spoke to most probably all of those companies who are in the customer or potential customer. So this is the learning over my last 5-6 years in this market. So one, we are seeing a demand for a small chip inductor that goes into automotive market. That's most probably will be the fastest way to get into the market, because we got order from 3 competing companies for that. And those are used for some of the autonomous sensor application, and some of the power inductor application goes into onboard charging. Second market that we are seeing a strong demand is the data center power system. And last but not the least, the lamination product that goes into motor and generator. It's a vast market. It can be anywhere, but we are seeing when there is a need for miniaturization and efficiency at the same time, which is a high speed application like here. Like EV might be a little bit later, but surgical tool like handheld devices, industrial drill bits, some manufacturing. So those are like the fastest way, and we are seeing demand, and we already took a couple of sample orders from those customers.
Okay, I have to stop it now, otherwise we're running too much behind in time. If there's no very, very urgent question that would be uttered from the jury, of course, I move on to the next team. Again, an online team. We have online with us from Turkey, Sumatrix.
Hi. A minute, I'm sharing my screen right now.
We see you, we see the screen, not
Okay.
yet in presentation mode.
All right. Just a minute. Now it works.
Yep, perfect.
Okay. Hi, this is Rumeysa, CTO from Sumatrix Biotech. Today, we're going to talk about a huge problem awaiting us in the future. According to UN reports, the agricultural production must be increased, as it would be difficult to feed the growing human population and as the arable area decreases sharply over time. Given concerns of feeding a growing human population in a changing climate, we should need a solution. And hydroponic farming is an excellent solution. You can make production in your single room apartment or in a space station as well. And you don't have to use soil or in excessive water. Plus, you may have bigger yields in a shorter time frame if you do hydroponic farming. It all seems perfect, right? But as a Sumatrix team, we saw the point where the problem gets deeper. What is the actual problem then? First, let's know the plant growth media used in hydroponic farming. Mainly used media are rock wool, cocoa peat, and perlite. Rock wool has a huge problem of waste. Cocoa peat must be imported from Asia mainly. And perlite is a dust hazard material used in this field. Secondly, all hydroponics require closed water circulation system, which is problematic due to the operational costs and for it to cause additional problem, the worst one, waterborne diseases. We offer a better solution, hydrogelponic, a new brand growing media for hydroponic farming. We integrated with sensors to control pH, temperature, and water content of the system. We have already tested our growth media for microgreen production, namely basil, and it was a very successful attempt. So now we focus on different prototypes, vegetables such as tomatoes. Now let's compare with other conventional materials. As you can see, we promise way better results in terms of water, energy utilization, and carbon dioxide emissions. Also different from others, it has almost 100% water holding capacity, which frees the overall system from the usage of water circulation system. No water circulation means no risk of waterborne diseases as well. And finally, it is 100% biodegradable, so no waste is produced like others do. At that point, you might ask, where does the inspiration come from? In Japan, a company produces synthetic-based polymer film for hydroponic farming. However, the technology behind our solution is simply bacterial cellulose-based material. When we compare it with Japanese solution, our hydrogel has 3D matrix, which enables the carbon dioxide and oxygen transfer, but also ion exchange as well. So it is much more soil-like material. Now let's see what differentiates us from other biocellulose producers. First, we have zero waste production procedure. We use ecological waste as a carbon source. And I saved the best part for the last. We increase the reaction rate almost 2 times so that the cultivation duration takes 3 days only. The normal protocol achieves it in 7 to 10 days. Now let's go back to our main competitors in the market. Including all the parameters, when we calculated the price of our material, it is much more affordable. Hydroponic farming is expected to double by 2028. Thus, the growing media market is also expected to increase in accordance. Our goal is to replace other growth media materials in the market. Specifically, we target 2% of the growth media of the European market. We plan to follow B2B business models, so our customer profiles are commercial hydroponic producers mainly. What did we do so far to reach our goal? We have already collaborated with well-known commercial hydroponic farmer Plant Factory for data validation. Also, we collaborated with some research institutes, municipalities of Turkey, and funded by government. Now we are looking for strategic networking, partnership, and investment for scaling up for potential customers such as bacteriocellulose users and hydroponic farmers. Also, companies who are interested in circular economy through sustainable waste management. We are a very dedicated team of 6 people. We believe that we can make a difference in the world. Join us. Let's make the world a better place together with us. Thank you very much.
Thank you very much. Konstantin has a question.
Yeah. Okay, Rumeza, yeah, thank you very much for this very interesting and impressive presentation. It seems that you only have advantages with your material. So let me just ask one question. You said, or you mentioned that your production costs are about 20 to 30% lower than materials which are now on the market. So how about the strategy to, or the price strategy to sell your products? And I don't know if you have really at this time pilot projects with companies. How is this? You have already a real laboratory for that, that you can improve your material?
Actually, our project started in a university laboratory, and now we are independent. We have an independent laboratory now, which is almost 30 meters square, and still we need to scale up. But the production estimate, the price estimation depends on for modeling and simulating using some softwares. So, and also we have now we enter the market, not market, but we have potential customer in Turkey. 2 of them we are contacted now, and they use our material, and we are simply getting some data validation from them. Yes, I'm not sure if it's the right answer for your question, but
yeah, thank you. Yeah, I think this is a real important thing for you to prove that your material works in real life or in real farming life. Yeah.
Yeah, we're about to prove that.
Thank you.
More questions from the jury. Ferdinand?
Yeah, a quick one. I wasn't really sure I got it correctly. Your product that you will plan to sell to the market, is this hydrogel, or you sell the entire plant growing system that contains this material?
Thank you very much for this question. It will help us to enlighten the strategy that we're following up, actually. Actually, we're planning to sell both. Because we produce bacterial cellulose-based hydrogel matrix in a dry form, and we can provide this material to not only hydroponic farmers, but also companies or sectors which are really interested in producing bacterial cellulose as well. So, but regarding hydroponic farming, we are planning to sell the hydrogel, which is the system integrated with sensors and of course, including the growth media as well.
Thank you.
Garrett has a question.
Rather general question, referring to the market potential of indoor or hydroponic farming. As you probably know, there's a famous startup here in Berlin, Infarm, addressing this market. They have been quite successful in acquiring money from investors, but still there's some discussion on the sustainability of the market perspective in this field. You found a company here, so obviously believe in the market potential of indoor or hydroponic farming. Could you briefly elaborate on why you are convinced that there is a huge market growth potential for the future in this field?
Hydroponic farming. Yeah. Because of the changing climate and the water scarcity program, there are already registered European Union projects regarding water scarcity, and because of the COVID, the pandemic, these kind of projects are accelerated, and because of that, now especially Europe and also Saudi Arabia concentrated on hydroponic farming without using any water. And also as the arable area decreases, the hydroponic farming getting more and more attention, and it will definitely increase more because of the climate change. And because of, thank you, Semra. By the way, Semra, our founder, is here as well. We are together right now, and the regulations, the European Union regulations also is very clear about this. So yeah, I can say that actually.
Okay, maybe just to add up, you mentioned Saudi Arabia as a potential market. I've heard also that there's a lot of investment happening into this indoor sphere. So you're explicitly addressing this market, like Saudi Arabia, maybe some other states who have some certain economic potential, but not so much area for classic farming around.
Yeah, this is a case in Saudi Arabia. Actually, the hydroponic industry, let's say, hydroponic industry focused on also Saudi Arabia as well, Dubai, for example. There are also already ongoing projects on Saudi Arabia, which are both European-based companies and also US-based companies as well. They have projects on Saudi Arabia nowadays.
Thanks a lot.
Okay. Right, I think those were the questions. So does anybody have another one? Okay, well then, thanks very much. Moving on, if I'm not mistaken, to ICOMAT from the UK. Richard, the floor is yours.
Great, thanks. Right, I'm gonna share my screen.
Yeah, see it well.
Great. Excellent. Right. Good afternoon, everyone. I'm Richard Hardy and I'm COO of ICOMAT. ICOMAT is on a mission to unlock the performance of composites to enable lighter cars, planes, spacecraft beyond what is possible with the existing state-of-the-art production technology. ICOMAT sells technology that enables the production of cheaper, lighter, stronger, and greener composite parts. There is an unprecedented need for lightweighting in automotive. This is due to the electrification megatrend driven by government legislation and the drive for greener transport. Composites can significantly reduce the weight, but are prohibitively expensive in automotive. Whereas in aerospace, they've been replacing metallic parts with composite parts for many years. Their problem is, how do I make my composites lighter? Excuse me. Weight directly affects CO2 emissions, as does material usage. If both are reduced, it significantly reduces CO2 emissions. Current manufacturing technologies just cannot meet the weight reductions demanded, and this is driving significant change in the production processes. Lightweighting is key across all sectors, each with their different targets, but the same goal, weight reduction. Both existing and emerging markets have huge potential. Composites are strong in the direction of the fibers only. Therefore, when making a laminate, you have to put material where it is not needed. If you could curve the fibers, then you could reduce the layers of composite required. Unfortunately, existing technology cannot steer fibers in a way that achieves the productivity or quality demanded by industry. The main competition is from 3D printing, of which there are many different technologies. Significant amounts of money have been raised. However, these technologies are not the answer to high volume production. After 10 years of development at the University of Bristol and 3 years at AdMaCom, we have produced the world's first fully patented machine capable of high-rate, defect-free fiber steering. The machine is scalable and can be dropped into existing production lines. We are able to use off-the-shelf materials, including not just carbon and glass, but biofibers such as flax and hemp, making the technology future-proof. Here is our technology steering 100mm wide tape at 0.2 meters per second. Fully validated results show the huge weight savings that can be achieved at both part and vehicle level. The right material in the right place, and this is only achievable at rate using the AdMaCom technology. In aerospace, compared to existing state-of-the-art, we have seen a 65% weight reduction on a section of the lower wing skin. In space launch tubes, we have seen a 20% weight reduction and significant increase in buckling load capability. We sell or lease the technology and have annually recurring revenue from support, maintenance, and software. In automotive, for example, we can sell directly to OEMs or their tier ones. We have recently completed a pilot line and are ready to move into machine sales. We have blue chip customers at different stages in the sales pipeline. We have a solid team that is ready to scale, as well as a solid base ready to scale. We are looking to raise a Series A funding round of $16.5 million for the next 24 months, with the goals of 5 machine sales and 5 high volume production opportunities validated by a machine placement. We will also expand into Germany and the USA. So please come and see us, have a web call, drop us an email. Thank you for listening. Please let me know if you have any questions.
Thanks very much, Richard. Ladies and gentlemen from the jury, any questions?
I always go first, right?
Please do. That's the...
Hi, quick question on my side on the equipment that you're about to sell. So in the price range, when you sell your equipment to the market, how does that compare to the conventional producer equipment or the conventional equipment manufacturers? Is that more expensive in terms of the volume it can produce, or generally more expensive, or is that comparable?
And our equipment's pretty comparable, if not at a lower price. I mean, some of the competitors, their systems would start from sort of 3 to 5 million, with some smaller heads around the same sort of cost point as ours.
Ainara, and then Konstantin. First, Ainara.
Yeah, sorry. So I have a question about the business model you have in mind. So you have the equipment, and this equipment produces some coatings or the sample with some properties that are aimed to an end user, or it has like some application, right? I guess that you need to adapt your equipment ad hoc to produce different materials, or to fibrillate or coat different materials to end up in different products for a range of potential users. So my question is, how do you see that viable, in the sense that to adapt your equipment to the different materials you can produce for the different applications?
Yeah, so our material, our equipment would take typically a roll of material, whatever material that is dry or pre-preg carbon or hemp or flax or glass. So our equipment has a base unit which doesn't change, and it has add-on components that are specifically designed for the different material types. So that's how we would manage that. So we would have, like I say, we have a fixed base model. So we're not doing constant modification of our equipment. And we have several different add-on units that are specifically for different applications.
And that goes then with my second question then. So if you have these add-on components with your protection strategy, with your IP strategy, how do you do it? In the sense, you have protected, I guess, the equipment somehow, or and then you need to protect every add-on you create for each customer you have, just to have your business like with a proper IP protected strategy.
Yeah.
Or
So I mean, we have a fully patented base level properties. We capture all of our IP, and we are currently patenting any other invention that relates to something that's process specific. So if during assessment of a material we find we invent something that is novel, related directly to that material, we would protect it.
Okay, yeah, thank you.
Okay, one more question, Konstantin.
Yeah. Okay, yeah, one question about your distribution process. How you get in touch with your customers, because as I understood, you already sell these machines, and that means you're on the market now. And yeah, how you get in touch with your customers, and usually how long you need for convince them the process to buy such a machine.
Yeah, so obviously we have a sort of a business development team that is sector based, so aerospace, automotive, etc. And this is how we contact our customers. Our sales cycle is usually around 12 months, so sort of a 3-month specification period and a 9-month delivery on equipment. Although, I mean, that on volumes, obviously, that if people place larger orders, then we can accelerate that process.
Yeah. Is there a free pilot phase that they maybe can test the machine and give it back, or how you work it out?
So how we are trying to address that is that our first head sales will be into research organisations, or RTOs as we call them in the UK. And that allows members and also non-members to go to that facility and trial the equipment, assess its suitability for their process, or for their component, I should say.
Okay, thank you.
Super. Thank you very much, Richard. Round of applause. And next one up is Sol OLED. Welcome on stage, Campo.
Thank you, Oliver. Good afternoon, everyone. I'm here today to talk to you about Sol OLED, which is a spin-out company that, from the University of St Andrews in Scotland. So we're focused on making new emitter materials for solution-processed organic light-emitting diodes with applications in displays and other images. So when we talk about OLED displays, they're widely used in consumer electronics these days because they're very, very high display qualities. They've got excellent color reproduction, contrast ratio, and very low power consumption, all of which are beneficial properties. There's also many new OLED displays coming out where we can utilize different display form factors. So we can have transparent displays, flexible displays, and folding displays. Some of these are reaching commercial production now. When we talk about OLED displays, we're talking about an organic light emitting diode, which is built up from many very thin layers of organic semiconductors. The entire thickness of the OLED is actually less than the thickness of a human hair, and it's all built up on a transparent substrate, either glass or a flexible plastic background. Sol OLED is focused on producing new and optimized emitters for use in the key emission layer, where the electricity is converted into light in the emissive layer, and Sol OLED is focused on optimizing that layer within the OLEDs. If we look at the existing emitters that are used currently, most of them are based phosphorescent emitters that are based on the very rare metal iridium. There's not very much of it mined. 3 tons of it are mined a year, and it's all mined in Russia and South Africa with significant supply chain and ESG issues created from that. And it's currently costs you about 150,000 euros a kilogram. So it's not, so it's something that we want to try and eliminate from the displays. There's another issue when it comes to cost effectively manufacturing large OLED displays in particular, which is the way that they're manufactured. So existing displays are generally manufactured by a vapor deposition method, which requires very high vacuum, high temperature, and it wastes lots of the materials that are used to manufacture the display. So this results in a energy intensive and costly manufacturing method. An emerging alternative is to solution process our OLEDs, whereby using inkjet printers, we can actually deposit all our materials on the substrate quickly, cheaply, and at ambient temperatures and pressures, which is a much cheaper and less energy intensive manufacturing method. So to work on these new emitters that we've developed, we've got an extensive academic team that each of us has at least 4 years of experience in developing LED emitters, OLED emitters, and we've all been based at the University of St Andrews for several years. To support us, we've got working with several business-minded people, including Dr. Ian Muirhead, who's got extensive experience in the Scottish startup community where we're based, who's spent 35 years working with spin-out companies and startups and has raised over £30 million in various different fundraising rounds for startup companies. So let's talk about the materials we've got. So Sol OLED has developed a new class of material, operates through a mechanism called TADF, where we can, with very careful design of our molecules, the energy levels in the molecules will allow very efficient, fast emission from our emitter materials. TADF as a process has been known for about 10 years, and there's been a significant amount of work invested in making and designing new emitters. But until Sol OLED had developed our new class of our new materials, our dendrimers, no one else had managed to successfully produce highly efficient materials that worked in solution processed OLEDs. So we've developed the materials and we've done extensive testing of the thin films of the materials and fabrication of prototype OLEDs. And our prototype OLEDs, including the ones pictured here, have reached extremely high efficiencies, brightness, and excellent color points, which is exactly what the manufacturers desire from the materials that are used in their OLEDs. So if we talk about the OLED, the market for OLEDs, the sort of final market for OLED displays is massive. It's a rapidly growing global market that's going to reach $63 billion a year by 2025. If we break that down to just the emitter materials and the materials that are used to fabricate OLED displays, the overall market for the materials that are used to produce OLEDs is $2.5 billion a year by 2025. And a smaller component of that, because it's an emerging technology, is solution processable materials, which is growing from sort of about $1 million a year last year, and it's expected to reach nearly more than $250 million a year by 2025, which leads to a massive sort of annual growth rate. So to enter into the emerging market, SolarLED is contacted a number of different display manufacturers, and we're so far working with one of them in China, and their R&D, their head of R&D is very excited to invest to validate our materials in prototype displays in their R&D facilities. There's a number of very large companies and other sort of emerging display manufacturers that we're working with in an attempt to get more traction for our materials. So there's a number of companies that work in making OLED emitters. The first generation of very inefficient emitters, they're still used, and there's companies that are making these still. There's a number of companies that are making the much more efficient phosphorescent emitters. And there's a couple of startup companies that are focused on making the highly efficient emitters, but no one else is working in the niche of the market which SolarLED occupies, which is highly efficient organic emitters, which are optimized for solution processing. So we've reached a point where we're now looking for seed funding to grow our company, to support continued customer engagement, business development, and to try and accelerate our R&D program to expand the number of materials we have available. And we're also seeking technical support from anyone that's able to assist in developing high throughput materials testing and thin film fabrication so that we can more rapidly test and prototype our materials. So thank you for listening, everyone. Please get in touch and help with SolarLED and our vision for the future of OLED displays.
Thank you.
So I would like to start. Thanks for this nice pitch. Really a lot of questions, but I think most of them I will have to ask later. I understood that you're mostly tackling the display market. Unfortunately, there's not much of it in Europe, although I've learned at least there is a OLED production line in Berlin recently, which is quite nice. But the question is actually, is there a potential to transfer your technology to other application fields of OLED development and to tackle those markets? And the second question would be, are you looking for a licensing business model, or are you also considering producing the materials yourself here in Europe?
Okay, so thank you for your questions. On your first point, you're correct in that most large-scale OLED display production is based in East Asia. So between China, Korea, and Japan and Taiwan is the vast majority of production. There are smaller and emerging producers in other areas. There's some pilot scale plants coming online in the US, and as you say, there's some small production facilities starting up in Germany. So there is some smaller emerging suppliers in other areas, and they may be people that will sort of contact as we try and grow our market and get our early traction in the market. So there are some emerging producers sort of spread more widely. In terms of producing our material, we're able to produce it sort of up to multi-gram scales and enough for sort of materials validation by external customers. to grow up to commercial production, we would intend working with an external contract manufacturing organisation. It may be that that's associated with a display manufacturer, particularly if you look at some of the large conglomerates like LG and Samsung. They've got significant internal chemical production facilities. But so far, all the other emitter manufacturers are working with chemical manufacturers to then sell the final product. There will also be an element, we may be able to license the technology where we've got some application patents as well as the materials patents where we can sell the materials and license the application IP.
Thanks.
Further questions? Tonino?
Tonino?
Yeah, hi. So basically you're saying your material is more efficient if you want to process it by a solution, right? Compared to the other, your competitors who also produce TADF emitters. So I know that, let's say, they don't really target solution processed ones, but theoretically they could use it. There's no reason why not.
Yep, so there are other people that are targeting TADF emitters. None of them are in large-scale commercial production yet. One of the issues that comes with solution processing is the morphology of the films you produce is very, very important. And so lots of the small molecule TADF emitters that other emitter manufacturers have developed, there's lots of issues around solubility and forming crystals in the emissive layers and aggregation and the need to disperse the materials in a host material. So we can actually reach we've demonstrated the highest efficiency for a solution processed OLED, even in comparison to the phosphorescent emitters.
But generally, the problem is rather that efficiency of the emitter is just one small part. Why solution processed OLEDs is really, really difficult to, and it's not applied in industry. In a very little niche fields, but usually it's all.
So we're aware that most of them are vacuum deposited, and there has traditionally been issues around stability and color and efficiency of solution processed OLEDs. The general problem of solution processed OLEDs has been solved in at least one case with JOLED has reached commercial production. You can go out and buy a solution processed OLED display next week if you'd like to.
Super expensive ones.
They're not particularly cheap, but they are available. And now that the market has started, and it's a growing market, so we think it's a great time to be trying to reach into the market as it's growing rapidly from a small base.
Okay, perfect. Does the jury have enough information to form an opinion? Okay, thank you very much, Richard.
Thank you.
Not Richard, sorry, Camper. And now we're moving on to PCN materials from Greece. Back online. Not very well.
Can you hear me now?
Very, very silently we hear you.
Is it better now?
Yes, slightly.
Yes, slightly. Okay, will you talk a little bit more loudly?
This is kind of a digital distortion in there, but we hear you louder.
Okay. Let me share my screen.
No.
you hear me now?
No, it's got worse again, I'm afraid.
Sorry. Maybe the next team can go and we'll go later. Is that okay?
Yes, it's good. That's good.
Okay, so
Just keep it close to your mouth.
okay, okay, okay.
But we need your screen still. That's not up.
Yes, of course. Okay, do you see my screen?
Super, all set now.
Okay, thank you. So hello everyone, my name is Maria and I am an R&D scientist for PCN. PCN was founded in 2019 as a spin-off company for the Foundation of Research and Technology in Greece. We develop innovative photocatalytic titanium dioxide materials that aim to improve air quality and disinfect health-sensitive areas. Have you ever considered how much time we spend indoors? For most people, it's about 90% of their time. However, indoor air is 2 to 5 times more polluted than outdoor air, which can cause respiratory diseases and even premature deaths. How many of you are afraid every time you have to go to the hospital because of nosocomial infections? Well, I am, because superbugs can cause up to 70,000 deaths in Europe and the US every year. There are a number of places where the vulnerable must be protected, such as hospitals, schools, nursing homes, and so on. The solution we propose to these problems is titanium dioxide, which is modified. Our materials can work with sunlight or artificial indoor light to decompose pathogens and air pollutants. Namely, we can achieve more than 99% reduction of pathogens in just 10 minutes, 85% NOx removal in the same time, while producing near zero byproducts. Furthermore, our materials can give surfaces self-cleaning properties. PCN owns a strong patent portfolio based on years of research. We have patents in Europe and also in China. Of course, the problems we are addressing are not new, and there are some existing solutions. For the antimicrobial effect, silver nanoparticles are more commonly used. For the depollution effect, there are some titanium dioxide products already in the market. And for disinfection, there are common disinfectants, common cleaners for surfaces. However, none of these materials can combine all three attributes, and that exactly is the advantage of PCN materials. As you can see, we already have a wide range of applications in textiles, air conditioning filters, cement tiles, glass, paints, and also metals. We have managed to incorporate our material in about 10% in paints, and we have done 3 large-scale projects with. In 2014, the photocatalytic paint was used to paint the tunnel, and 7 years later, this tunnel still remains as white while saving money for the municipality in maintenance costs and also lighting needs. The other 2 large-scale projects with paint were painting the Greek Army Medical Center and some demo houses at Forth, and we observed that the nitrogen oxides level indoors remained lower after the application. There are some titanium dioxide products already in the market. In this table, you can see how we compare to them. What actually sets us apart from our competitors is the biocidal efficiency of our products, because no one else has that. We can also achieve better performance under indoor light and not only under sunlight, which contains UV, while producing near zero byproducts. Also, the price is another thing that makes our product more attractive. So we have already discussed what creates the need for photocatalytic products, and specifically our own. There is the market for photocatalytic products is already existent, and there are not many companies addressing those needs worldwide. Of course, the market needs will continue to grow due to the variety of applications. Let's move on to see our position in the value chain. We start with the supply of titanium dioxide precursors, which we then modify to produce the photocatalytic material, the powder. We give our powder to surface manufacturers, and they are the ones who will incorporate it in their products and then sell them to the end users. We aim to follow a pull marketing strategy with our clients being aware of the problems to which we offer solutions. Lastly, it is also important to specify that our profits will not only come from directly selling our products, but also from licensing and getting fees. PCN started with the seed funding of about 800,000 euros to set up the pilot line. Right now, we need to find investing of about 2 million euros to have an external partner produce larger quantities of our material so that we can focus on more large-scale applications and validation. And then the next step would be to expand production capacity by setting up the industrial unit. And this way we could address about 1% of the market needs and have a turnover of about 50 million euros per year. Here you can see the members of our team. George Kyriakidis and Vasilios Binas are the two founders of PCN and the ones behind the initial idea and research. Also, our team consists of 2 chemical engineers, 2 R&D scientists, 2 technical support staff, and the Big 5 venture capital, who are the initial investors. To conclude, PCN aims to alleviate acute social problems, and we have the technology to do that. I would like to invite you to visit our website to find out more about us, and feel free to contact us for further information. Thank you.
Thank you very much, Maria. Questions? Ainara.
Yes, I have a question. Thank you, Maria. My question is related with the lifetime of your material. Is there any saturation, or have you studied that?
Well, the most safe answer would be to tell you about the application we have, which in the tunnel has been for 7 years now. So the material remains as effective after 7 years. That's the most we have seen. In the powder form, we haven't noticed anything concerning. It does not, for example, change form or have corrosion.
Okay, thank you.
Thank you.
Another question? Tonino?
Very quick one. So you need light to induce the activity, photocatalytic activity. So which wavelength do you need?
Excuse me, which?
Which wavelength?
Okay. Well, normally titanium dioxide works with UV light, but we have managed to modify our product in a way that it can use visible irradiation. So it can work with sunlight, but it works as well with indoor artificial light, the lights we have in our homes. So.
Okay, great. Thank you.
Thank you.
Lovely. Any further questions? If that is not the case, and I don't see any raised hands of the jury, that's then the sign to move on. And I suppose we're up with Guardian from the US. Dan, the stage is yours. And thanks a lot to Maria, to Greece, of course.
Thank you.
All right, can you hear me and see me?
Yes, we see you well, and your presentation is there as well now.
All right, thanks, Oliver. This has been a really cool experience overall, so thank you. My name is Dan Esposito with Guardian, and we're advancing trace detection of matter. Talking about detecting a very tiny amount of material, which is critical for how we build and understand the world that we live in. In semiconductor processing, it's how we control the environment for putting down our materials that builds the chips for our phones and computers. We use it for drug discovery, clinical analysis, and even applications of environmental monitoring with tools like mass spectrometry. It's even how we responded to the COVID-19 pandemic in a lot of ways. We also use it for threat detection, looking for explosives and chemical warfare agents. And across the board, when I'm talking about looking for a tiny amount of material, it's often so small you can't measure it with traditional electronics. So what you do is you have to amplify it 1 million times to get it to that point of being readable. But that has a number of drawbacks. First, you have to employ things called multipliers. These require thousands of volts to operate, which means secondary high voltage subsystems, a special tuning that you have to do over time. And they need a pristine working environment or vacuum environment where you have to employ heavy, expensive, and power-consuming roughing pumps and turbomolecular pumps just to be able to use this technology. In some application areas, you have to employ multiple tools over a range of pressures you might be looking at, because nothing will work over all those conditions. And then finally, if you're interested in having field information where you can't go back to the lab where this other equipment is relegated to, you have to sacrifice sensitivity to reach portability. And what we do at Guardian is eliminate these trade-offs. So we're able to provide 1 million times amplification, and we do so using 10,000 times less voltage. What this means is we eliminate completely the high voltage systems and issues related to this kind of process. We also operate in open air, meaning any of the heavy and expensive pumps that we're talking about that limit portability and fieldability are not really as a requirement of the detector that we do. Now, the reason we can do this is from an awarded patent where we exploit some interesting properties of nanomaterials, a localized gating phenomenon that allows us to get this 1,000,000 times amplification using under a volt to do so. It's a wafer scale manufacturing process, meaning not only can we do added advantages like spatial resolution, but the cost to manufacture these is significantly lower than going through a traditional manufacturing approach. We have a second patent we're also going after that expands into a new device architecture that opens up opportunities for electron sensing and photo detection as well, which opens up new market opportunities I really won't even be able to get into during this 5 minutes. Our team has deep expertise in nanomaterials, nanomanufacturing, and device design, critical for going after a problem set like this. And we have a great support team with expertise into selling into government-based customers, selling into the semiconductor industry, as well as exiting a startup in that space, and deep expertise in analytical instrumentation design and scale up of manufacturing. Now, as we went out into the market to kind of understand where we would fit into this place, we have a platform tech. So at the very core, what we're doing is producing the sensing technology that enables operation in these different areas. In some cases, potentially like in the eye mobility spectrometry case for threat detection, we might be just supplying the core enabling chip in that space. And others, like in the vacuum gauge market, where we have the potential for the world's first full range vacuum gauge, we actually are going to be pursuing a productization of the core enabling technology. And others, like in mass spec, and specifically with applications around portable mass spec, that actually might come through a partnership application. So beyond what we can do terrestrially, we also recently won an award with the NASA Science Mission Directorate for the advancement of mass spectroscopy and solar system exploration-based missions. And we're hoping to convert that into a $1 million grant that's currently pending with NASA right now. We have an active $1 million National Science Foundation grant covering the development of the core sensing technology and its manufacturing scale-up. And then we're moving into productization areas as well with that. And we have one other tranche of funding coming in, or hopefully coming in, through the counter weapons of mass destruction world for the application of these in tools for eye mobility spectrometry. So where we are right now is we're moving towards wafer scale production in the next quarter, and we're looking to build into engineering prototypes and then march towards pilot studies. And to do so, we're raising our first round. And we have an interesting opportunity there where the National Science Foundation will match up to $500,000 in non-dilutive funding to a qualified investment round. So we're here to look for both end-use testing partners and investors interested in working on the future of analytical instrumentation, semiconductor processing, drug discovery, and security. Thank you.
Thanks a lot, Dan.
Sure, yeah.
Do we have questions?
Hi, Ferdinand here. Can you say something to the mass sensitivity of your process? So how high does it go in masses?
So in the original patent, we may have had a upper bound limit of what we were looking at in terms of mass. With the second patent we're filing right now, it's adding a kind of almost like a protective layer around the core sensing material. And what that allows us to do is not really worry about the upper mass limit. As long as I can impart charge, I'm okay. So in some application areas, we've heard from the mass spec folks in the electron multipliers, they have some issues with how they dial all that stuff in. It has not been tested. We hope with this NASA funding that's coming in, we'll have that data, but we don't see any obvious reasons to have a cap on the mass that we're receiving. As long as we can impart charge, we're okay.
If you have a protecting layer on it, does it impact the avalanche, the multiplier of the electrons?
So it's actually not an avalanche process. So it's a way to think about it would be, we have a way to locally capture charge, and we use that charge as a way to gate the nanomaterials that we work with. And through this gating process, we can exploit the high mobility of the materials to get out this high signal at the other end.
Thank you.
Yeah.
Other questions?
Yeah.
No, it seems the jury is happy. Meaning you have explained everything extremely well. Thanks a lot, Dan. Another round of applause to you.
Thank you, appreciate it.
And now we have, well, we will have up on stage our last team before we can move into a little coffee break. Clean Ocean Coatings from Germany. welcome on stage.
Thank you. So I know we're all thirsty and tired, but I do have something I want to talk about with you. So we all need the ocean. Now the ocean needs us. Very wise words, if you ask me, because the ocean needs us to solve a very well hidden problem. Do we have any boat owners here tonight? No? Then I guess you probably never have heard of biofouling. Biofouling is the growth of algae and seashells on ships, and it causes an increase of fuel consumption of up to 40%. This causes an estimated damage of 150 billion euros annually. And therefore, more than 100,000 tons of toxic anti-coatings are applied every year. And these are the actual problem, self-eroding coatings. They are designed by purpose to wash off over time, leaching toxins and microplastic into the ocean. So by the end of their lifetime, 50% ended up in the ocean and therefore in your sushi. So a merchant vessel is in dry dock every 5 years. I don't think it's funny, but okay. So a merchant vessel is in dry dock every 5 years, and that is when it gets a new coating. And as you can see, that is neither a fun or healthy job. And here comes our solution, a coating, a toxin-free hard coating, which does not wash off. So our magic is a uniquely smooth surface, which is easy to clean, and it is more durable than conventional coatings. Due to the smooth surface, we have less friction. This can save the shipping company 600,000 euros per vessel per year. The coating is a combination of a nanostructured patented particle and a polymer matrix. It is a completely solvent-free two-component system. And the global marine coatings market is in the size of $11 billion. So 4.5 billion belongs to the commercial shipping, and this market is forecasted to grow by 7%. So our goal is to get on newly built vessels, because the customer usually likes to stick with the same coating system. There are 90,000 vessels globally, and around 3,000 vessels are ordered new per year. And 30 to 40% of the customers choose a premium coating, and this is our price segment as well. A coating is disruptive. 80% of the market is owned by 5 global players, and 90% of the customers still use self-eroding coatings. And we not only stand out in sustainability, but as well in longevity and in ease of application, because unlike other sustainable solutions, we will be applicable with standard methods. And we do have the customer validation. We not only win awards, we already coated 3 boats, and we have 4 test patches on cargo vessels. So this is the latest one we've done last year in China. And our oldest test patches are already 7.5 years old and convinced our pilot customer to coat a whole vessel next year. So we need to get this coating right before we scale, but then it is a very low cost and highly scalable technology. So imagine 2030, when we will coat 350 boats and make 70 million of revenue. And not only that, on the way, we will save 850,000 tons of CO2 equivalents in GHG emissions, 1,250 tons of microplastic, and 440 tons of solvents. And here's our team. For the science part, that is me, an international experienced engineer, and Patricia, who developed the coating the past 7 years. And for marketing and sales, we are supported by Benjamin and Simon, in total 17 years of experience. I don't know why he turned blue, but okay, it's late. So what is still missing? Currently, we're developing the spray application process. And then in early 23, we aim to coat this pilot with Rod Bahn. And as well, as soon as we can spray, we already have a pipeline for paid test patches. So currently, we're closing our first angel round. And as a cherry on the icing, we will triple this investment with the Corona Recovery Fund. So we need this 100K to finalize the spray application process. And when you're fast enough, there's one spot left. As well, we are looking for some lab space currently. So if you know anything that can help us, please let's get in touch. And we as well have some samples of the coding at the booth when you're interested. So.
Thank you very much, Christina. Over to the jury.
If it's possible. Thanks, Christina, for this interesting pitch. Always happy to see Berlin startups pitching at the AdMaCom. Thanks a lot. Very nice approach that you're following on. You said earlier that the market is divided between the industrial or commercial sector, but there's also a significant leisure aspect to it. Although we have no private boat owners here, obviously. But are you planning to address this market as well? Because I could imagine that there might also be some nice opportunities for pilot initiatives in this market.
Actually, we get inquiries every month from private ship owners because they are very interested in the sustainability aspect. Yeah. But the thing is that private boats usually are idle 99% of the year. And since this is completely biocide free, we don't prevent fouling from happening. So if a boat is not used at all, you need to clean it regularly. And this is, at the moment, there is no convenient solution for private boat owners.
Okay.
So this is one thing. And then of course you have a lot less coating. I mean, a big cargo vessel is 4,000 tons of coating with one sail, and one private boat is 30 liters maybe. And so, and the merchant, the commercial shipping industry, they usually have more than one boat. So it is definitely more attractive. And then the private sector really struggles with the cleaning thing.
Okay, makes sense. And what about the production of your material? Are you planning to produce it yourself?
For the beginning, we already do have partners for loan production, but then in the future, we aim to produce it ourselves. Yeah.
Okay, thanks a lot.
You mentioned that the product is solvent-free and you can spray coat it. Could you confirm on that?
And that's what we're currently developing. So we had the first trials at Viva, one of the biggest producers for these 2-component spray systems. And we still need to iterate on this. But like in principle, it is possible, but it's not at a stage that we can use it right now.
Okay, thanks.
But yeah, so we could do trials a whole day, but the results were not satisfying. So. Yeah.
So apparently your material is so durable and stable that it survives for years in saline water. So have you ever thought about any other use case applications outside of the ocean maybe?
Yes, it has already been tested as well on a carp pond, and it is suitable as well for fuel or food tanks. And we are as well already talking with a strategic partner who would, together with us, develop the more on land applications.
Konstantin, yeah?
Yeah, maybe one question. Compared to your competitors, the market price, because there are not so many competitors, as you mentioned before. So how is the market price related to your competitors?
Yeah, so I mentioned this premium price segment, and we're as well in this premium price segment. Yeah. So currently it's around 40 euros per square meter. And this is so, which is very good because they wouldn't be, they wouldn't pay more in the beginning for our coating, even though it can possibly save one coating cycles. So.
Okay, thank you.
Okay, I think that was the round of questions. That completes our startup pitches. Thank you very much, Christina. And now I'm very happy to announce 2 things. Firstly, you'll be let into the break in just a minute, just a further announcement. So the break will be shortened a bit, because we're running behind in time a bit, and the jury has already agreed to make the decision in a shorter time frame than originally foreseen. So when you leave the room, please come back at 5 minutes to 5. Now, in the meantime, you can
vote, both those that are here in the room and those that are online. You can vote the crowd favorite startup. So get your mobiles out and hopefully you'll be able to, certainly those that are at home in front of the screens, they'll be able to screen the QR code. And hopefully also those that are here in the room will be able to do so. We leave it on during the break for a bit. So if it doesn't work in the first time, you can do it right after. Yeah, and that is the final words I want to make before the break. So please be back here 5 minutes to the hour for the winners announcements and enjoy the break.